Lift drawings for starting construction. In this video, I'm going to talk to you all about why every project, I don't care if it is a concrete structure, a steel structure, hospital, laboratory, airport, or multifamily building, or residence. All of these buildings, every project has certain lift drawings that need to be done at the beginning so that you can start out properly. Now, a lift drawing is where you take information from all the different drawing sets and you lift them into one for coordination and to make sure that you're able to execute properly. A lot of people think, well, I don't need field engineers, I don't need lift drawings because I'm not doing self-perform. Wrong. You need lift drawings. And what I'm going to do, because our first project at Leanbelt is a $120 million multifamily project, I'm going to show you how even a project that's built out of wood, that's fairly simple, requires different types of lift drawings. It is key because we have to QC different aspects and make sure that different phases of work go in right. So right now I'm going to switch over to my computer and show you some examples and an example of what a normal industry lift drawing looks like and the power that you will have if you implement this in pre-construction on your projects to prepare work. So if you're into that, stay with us on this video. Okay everybody, I'm here on my computer screen as promised and I'm on my Jason's creative board on Miro. I've got the images ready to go and I'm excited to show these to you. If you're checking out this video on your phone or on a small screen size, I hope you can see it. Bottom line is I'm simply trying to show you an example. If I'm just talking to you all the time, my fear is that you can't see the way that we do it, then you take it and improve it from there. And so I'm going to give you just a couple of examples. So the topic that we're discussing is lift drawings for starting construction. Now, we all know that large general contractors in construction produce lift drawings that look like this. And I'm shouting out right here, Oakland Construction. This is from a boot camp that we did with them a while back. So it doesn't bother me that they have the brand up here, but this is the typical lift drawings that a Hensel Phelps or Kiewit or an Oakland Construction would do for concrete out ahead of time. And field engineers would do these. And you would have field engineers queued up and ready to go for your project, whether you're doing self-perform or not, for concrete, masonry, and then lift drawings for the rest of the building, but mainly doing in-wall and overhead inspections and then closeout commissioning, things like that, right? So this is pretty normal. And lift drawings for concrete and masonry are crucial way out ahead. The point that I want to make is that if you're on a different type of a building, like let's say you're on a data center or a multifamily project, a remodel or a residential project, you still need lift drawings, right? So you need lift drawings to start construction. And I wanted to give you some ideas of some of the lift drawings that we're doing at the West Fillmore project for our first Leanbelt construction project that we're executing. So let's go ahead and go through these one by one, and I think you're gonna love it. All right, so let's look at this one right here. I've got a couple of examples for you, and this is a Leanbelt lift drawing. What we're doing here is simply, in this lift drawing, is taking all of the dimensional information from the plans, not from their CAD files, not from Bluebeam, but from the written plans. And our folks internally, ideally field engineers, project engineers, but sometimes you get some VDC help, literally drew every single wall and coordinated the dimensions of everything on this building so that they could verify anchor locations, anchor bolt locations, dimensions of walls, if there's missing information, right? So anything that was missing became an RFI. And the reason this lift drawing was so important is because we can't QC the edge of slab for these buildings, and we can't QC the bolt locations, and we can't QC the hold down locations if we don't know where they are exactly. So they put together this lift drawing. Probably, I'd say about 45 key items came out by way of, we didn't write RFIs because we were in design, but 45 items that would have otherwise been an RFI were vetted in this process. And so now, literally, this is what we can do. When we're out on site, we can set up our total station on our baseline and literally QC the edge of slab. We can QC QC the anchor bolt, the hold down locations. We can QC elevations, anything that we want to do, because this is all lined out. And so the reason this is so important is because it's a post-tension slab on grade, and we can't get this wrong, and we can't just go drill and epoxy this stuff later. So this allows us to get out of the ground fast as we start the first placement over here. And so this is a lift drawing that we did, even though it's not a big concrete commercial project, it's just a multifamily building. Let me give you another example of a lift drawing that you would do for any type of project. So we have 9 buildings on our project, and it's quite a big site actually. I'm really excited about it, but you'll see that we, in our primary control plan as a lift drawing, typed in our basis of bearings, additional control points, our property corners, and we were able to, and I showed you this video on the last YouTube video that we did in reference to coordinates, and we'll link you to that as well, but we actually plugged in the coordinates per building. This is building 1, and you'll see we have 1, 2 coordinates here, and everything is on this map. So if I want to see the basis of bearings, I got them right here. If I want to see the property corners so I can verify them, I've got them right here. All good. If I want to know, well, hey, that's all good and well, but how am I going to lay out the building? I've got the coordinates over here for the building, not to the edge of building, but for grid line intersections. Now, I'm going to draw this with arrows, and I hope this makes sense. Our surveyors are going to, not our surveyors, the surveyors we hire will come out, and they will actually traverse through the property lines back over to the basis of bearings and include that in a loop. And I don't know how they'll pick up this third point, but they'll do it somehow, and basically verify that the basis of bearings matches the property corners. And that is important because we want to make sure we're not in separate coordinate systems. And then what we're going to do, and I'll go ahead and use my little number dots over here, we're going to place primary control points around the project site. And guess what? The surveyors will come out and give us a northing, easting, and elevation for those points. Then what we'll be able to do is come over here and establish a baseline along that grid pattern on the building, and we'll be able to utilize that baseline to lay out points and turn 90s in here to the grid system and get anything that we need to for the actual building itself. So this is going to end up being the primary control plan. So what we'll do when this is verified, we'll publish the northing, easting, and elevation. When these are checked, we'll publish the northing, easting, and elevation. We already have the northing and easting elevation for the building. Once we know what our secondary control is, we'll go ahead and publish that northing, easting, and elevation, and then any other pertinent information, like for instance what benchmarks trade partners should use for these different buildings. And you can come up to this drawing and see everything in one location, and the trade partners have all of their layout and control ready to go. By the way, we have our title blocks ready to go. We're not going to do the numbering down here at the bottom until we have them all put together and we've come up with a naming convention. So if you're like, why does every one of those say A101? It's because this is just a template, but the drawing is in progress. So the next step here, the surveyors will go out and do their magic, and then we'll start to set up secondary control, then we'll publish it on the wall. So super cool. Let me give you another example of a lift drawing is required for a building like this, no matter how familiar you are with it. So this multifamily structure has different structural details, different types of hold downs, different anchor bolts, post-tension slab on grade, and there's different details in here that we need to know. So from a QC perspective, we literally went through here and modeled 2 units all the way up through the structure so that when we're out there QCing everything, we know exactly how it's supposed to go. I don't know about you, but anytime it comes to wood structures, I'm like, whoa. You're literally relying on the framer's knowledge. The construction managers typically don't know what they're looking at. Not now. We have lift drawings. We know how it all pieces together, and we can go actually QC the work. And there's many more. So you've got the typical concrete lift drawings and masonry lift drawings that we do. And let me just say, on this building, we'll also do a lift drawing for roof slopes, for ceiling heights with MEP. We will do cut sections for the site utilities. We will do a double check of all site flat work to make sure it doesn't exceed the slope. The bottom line is, it doesn't matter what kind of project you're on, you need to do lift drawings early on so that you can QC your work and know exactly what you're looking at. So here's what I'm going to do. I'm going to turn this into a blog post for you, but I'm going to give you some cool information about lift drawings and invite you to reach out to us if you ever have any questions about this. Remember, a lift drawing is lifting all the pertinent information from multiple sets of drawings and putting it in one location so that you can build it. If you can't draw it, you can't build it. And I'll leave you with this one last bit of advice. We do lift drawings, number 1, so we can learn the building, number 2, so we can find problems in advance, and then number 3, so that the trades have something they can build from, in that order. And if you do this, and it's remarkable, you will avoid many quality pitfalls right out of the gate, and you'll go faster. I hope you've enjoyed this video. On we go.